Hello there and welcome to the June 2018 paper. Here we're looking at question 6. So using the standard results for the sum of r squared and the sum of r, show that the sum on the right is equal to the expression on the right. Sum on the left is equal to the expression on the right. So let's start with the left hand side then. So the left hand side is equal to the summation from r equals 1 up to n. We could start by expanding brackets. So 9r squared minus 12r plus 4. Let's now split all of these summations up. So it's r equals 1 to n of, we factorise the 9 to the front, and it's r squared, minus 12 times the summation of r equals 1 up to n of r, and then plus the summation of n lots of 4s. So let's now write out the formulas for these. It's going to be 9 over 6 n plus 1 2n plus 1 minus 12n over 2 brackets n plus 1 plus, and the sum on the right is just the sum of n lots of 4, so that'll be 4n. So let's now simplify into a common denominator. Let's make it a common denominator over 2. So it's going to be 3 over 2n, n plus 1, 2n plus 1. Let's keep this minus 12n over 2. And let's make this last term 8 over 2n. Okay, why do we do that? Well, now because I can now factorise out the half to the front. So it's going to be a half. What else can I factorise to the front? I think I can factorise n to the front, because every term here has an n in it, and that's all. I nearly could factorise an n plus 1, but the last term doesn't have an n plus 1 in it, so I can't factorise it out from all three terms here. Let's see what I've got now inside the brackets. It's going to be 3 n plus 1 2n plus 1 minus 12 lots of n plus 1 plus 8. So let's now expand the bracket. This is inside the square bracket, so it's going to be 6n squared plus 9n plus 3 minus 12n minus 12 plus 8. So let's now simplify what we've got here. It's going to be 6n squared. It would be 9 minus 12, that would be minus 3n. And then it's going to be 3 plus 8 is 11, minus the 12, that would be minus 1. And that's exactly what we're looking to show it equals onto the right hand side. So there we are, lovely. We've shown that the left hand side equals the right hand side for positive integers n. Right, then let's move on to part B then. So we need to find any values for n for which, oh, there's a little typo in the question here. It's 3n cubed in the question, actually. 3n cubed. Find any values for n for which this expression on the left, quite a difficult expression, it starts from 5 up to n of the thing we've just found, plus 103 lots of this cos expression here. It's r times cos r pi by 2. Okay, so let's get started. So I think what we'll do here is we'll start by splitting up the first bit into r equals 1 to n of the summation that we've just found. And then we'll subtract the summation from r equals 1 up to 4 of the thing we've just found. So that will now give us just the sum from 5 up to n. And then we'll have to sort this thing out at the end as well. So we'll have a think about that in a second. But first of all, it's cos r pi by 2. Okay, so on the far left here, so we're going to have n over 2 brackets 6n squared minus 3n minus 1 minus, now we'll put the numbers in. This is a short summation here, so we'll just put the numbers in from 1 up to 4. So 1 times 3 is 3, minus 2 is 1, 1 squared is 1. Putting 2 in, you're going to get 6 minus 2 is 4, 4 squared is 16. Putting 3 in, 3 times 3 is 9, minus 2 is 7, square it, you get 49. And put 4 in, 3 times 4 is 12, minus 2 is 10, 10 squared is 100. Right, let's now work out what this summation here is going to be. So it's going to be 103 times something. So let's start by putting numbers for r in and see if we can spot a pattern. So let's put r equals 1 in, and let's draw the cos graph to give us a picture of what's going on here. So pi by 2 is going to be here, pi is going to be here, down at minus 1, 3 pi by 2 is going to be here, and 2 pi is going to be up here. So when r is equal to 1, it's going to be pi by 2, which is 0, so the output there is 0. When r is equal to 2, it's going to be pi, 2 pi over 2, so that's going to be pi, so that's going to be a minus 1 on the output, but we also have to substitute in the 2 here, so it's going to be 2 times minus 1, so when r equals 2, the output is minus 2. When r equals 3, it's going to be 0 again, and in fact that's going to happen for all the odd numbers in this little sequence here. So in fact there's no use going for the odd numbers anymore. So when r equals 4, let's put that in now, it's going to be 4 pi over 2, that's going to be 2 pi, but then we need to put the 4 in the start as well, so that's going to be 4. And then the same pattern is going to carry on. When you put 6 in, that's going to be 6 pi by 2, that's going to be 3 pi, which will be back down at minus 1. So it's going to be minus 6, then 8, then minus 10, then 12, then minus 14, then 16, then minus 18, then 20, then 22, minus 22, then 24, then minus 26, then 28. Now let's add this together. If we just group these into 2's here, that'll be the easiest way to add all of these together. Each of these groups counts for 2. And there are going to be 1, 2, 3, 4, 5, 6, 7. There's going to be 7 groups. 7 groups of 2 is 14. So 14 times 103 gives you 1442. Now let's simplify it with the numbers that we've got to subtract here. So 1442 minus 1 minus 16 minus 49 minus 100. And that will give us 1276. So all of these numbers at the back here will simplify to 1276. And this is also, if we expand the brackets on this, 3n cubed minus 3 over 2n squared minus n over 2 plus this value here. And now we need to solve that this is equal to 3n cubed. So let's cancel out the 3n cubes on both sides, and we've now got minus 3 over 2n squared minus n over 2 plus 1276 equals 0. Let's now solve this. Let's just put this straight into the polynomial calculation solver. And then when we put that in, we'll type it all in. We're going to get n equals 29. That's the only whole positive value that's going to come out of that calculation input. So there we are. That's the answer for question 6. Then, in fact, you can also see that summation of the cos one. If I just delete this little bit up here, then if we do it on the calculator as well, you can also see that calculation here, before you times by 103, will also give you 14. So you can also use that mode on your calculator to check that you've done the work correctly. But we've proved it just by using our own kind of knowledge of the cos graph as well. So there we are, that's the answer for question 6. There are 10 marks for that question there in total. Feel free to use your calculator to check that as well. And yeah, let's move on to question 7.